easier to be very specific about what we'd like. So, first thing is, what the heck is this? Well, this is not multiplication. This right here is pronounced f of x. And you'd be forgiven for thinking this was f times x, and also for asking, well, how will I know when it's multiplication, and how will I know when it is a function? And the answer is it comes with context and it comes with practice. And until you feel comfortable, the answer is you're going to ask me a lot. You're going to ask tutors a lot. Is this multiplication? Is this function notation? So it's going to take a lot of practice. And I'm going to agree that this is awkward that we use the same notation to mean two wildly different things, and to say that I wasn't around to argue with anyone, unfortunately. So I would have gone to bat for you, except it was a few years before I was born that they came up with this. So rather than talk about all the details, I'm going to go right into it, give you the example, and use that to help us determine what the heck is going on. So I'm going to tell you that f of x is 2x cubed minus 3x squared plus 1. So that's the pattern that I'm going to name f, which comes from, I assume, some version of function, although I don't know that it was originally in English or not. G of x, write that in, g of x, just like the f of x, is 3x. It's a much simpler pattern. So we've got two function patterns, and we'd like to evaluate this at different values or even different expressions. So the first one asks us f of 3. Okay? So what I'm going to do is I'm going to rewrite f of x. I'm going to write f of pink box. So f of x, or f of pink box, is 2 and then x cubed. So that's going to be box cubed minus 3x squared. So that's box squared plus 1. So in other words, whatever comes in here in the pink box, we're going to put everywhere we see another pink box, which is just another way of writing an x in there and then saying 2x cubed minus 3x squared plus 1. So f of 3 is going to be 2 times 3 cubed minus 3 times 3 squared plus 1. Do you see that everywhere there's a box, we put in a 3. So box here, 3. Box here, 3. This one, no box, so the 1 just hangs out. Okay, so that's going to be equal to, let's see, 2 times 27 minus 3 times 3 squared is 9 plus 1. So that's going to be 2 times 27, that's 54, minus 27 plus 1. 54 minus 27 is 27, plus 1 is 28. Now, honestly, this answer, 28, far less important to me than this setup. So take another look at that, see if you see whatever the x is. So in this case, it's going to be 3. I put it in wherever I see that x, or the pink box. So f of 0. F of 0 says, wherever the pink box is, I want to put a 0. So f of x is 2x cubed minus 3x squared plus 1. So f of 0 is going to be 2, right? 2 times 0 cubed minus 3 times 0 squared plus 1. That's going to be 2 times 0 minus 3 times 0 plus 1, which is, well, just 0 minus 0 plus 1, so that's 1. Okay. Let's follow the pattern further. Now, this gets a little bit weird, but it asks, the first one was f of 3, second one is f of 0, and this is f of t. Now this is going to sound a little silly, but all this is asking is it's asking you to take f of x and replace the variable with t. So f of t is 2 times t cubed minus 3 times t squared plus 1. So wherever the pink box or the x is, I just put the t into. So 2 times t cubed minus 3 times t squared plus 1. Okay, let's move into G land. Now this is g of 12. And here's my g of x up there. I'm going to rewrite that as g of box. And I'm going to get another color for this. And this one's much simpler. G of x is just 3x. So it's g of box is 3 times the box. And let me use blue for this. There we go. So g of 12 is just 3 times 12. Whatever's in there, whatever's in the parentheses, is going to go right there, 3 times that, which in this case is 36. Now, why does this one have a plus 1 and this one doesn't have a plus 1? Well, if we look at the initial function notation examples, this pattern f of x is 2x cubed minus 3x squared plus 1. So this has a plus 1 in it. G of x doesn't have a plus 1. It just says whatever x is, multiply by 3. Okay, so let's go a little further, and then things get a little wilder. G of x plus 1. Now this one is weird enough. I'm going to rewrite the box version. And again, with the boxes, g of whatever the x is, or the box, g of box is 3 times the box. So g of x plus 1 is 3 times, and then x plus 1 goes in there. And I know a lot of people are about to say, wait a minute. Wait a minute, wait a minute. This was g of x is 3x. So how is g of x plus 1? How are we supposed to even deal with that? How is this x and that x? And it gets very confusing. And then I'm going to say something that is going to probably not be any help at all, but it is true. This x is not that x. This is just a sample. So when I look at these examples, this is like if I were telling a joke, and I wanted to tell a joke about 2 people who decided to go to the ice cream store. And I could say 2 people went to the ice cream store, and you know, this one person is named Frank, and the other person is named Gloria. Now, the names were just helpful for you in the story. So if then you meet someone named Gloria or someone named Frank, you don't think that they went to that same ice cream store, because just because they have the same name doesn't mean they're the same person. Same thing here. G of x equals 3x is just an example. This x is like a model. It's showing you how the pattern works. So every time you see g in this problem, it says whatever's in here, multiply by 3. So if there's an x plus 1 in here, I'm going to multiply by 3. And if it gets even more exciting, there's a 3x plus 4 in there. I'm going to multiply that times 3. So let's see, 3x plus 4 times 3, I think I get 9x plus 12. And again, these are the answers, but honestly, the answers are much less interesting to me than the setup. Okay, let's try one more. And the last one is going to look funny, but it's going to be very, very familiar after a while. And I'll remind you, g of x equals 3x, which means g of box equals 3 box. And I want to know what is g of x plus h. And you might say to yourself, what is h? What, suddenly there's an h? And the answer is yeah, there's going to be an h, and this is going to be one of the foundations for setting up calculus. So I'm going to take this. I'm not going to worry about calculus. I'm not going to worry about what h is or what x is. I'm just going to follow the pattern. And that says whatever's inside here comes out here and gets multiplied by 3. So this is going to be 3 times the quantity x plus h, which is equal to 3 times x plus 3 times h. And a very important result about this to really focus in on, because this is going to be something that's we're going to be working on for a while. Like, a while means we're going to keep working on this concept till you get to calculus and into calculus. And that is, when I write x plus h in here, the x and the h are in the same place together. They have the same status. Notice that I don't just stick an h on at the end. Both the x and the h get their own 3. And that's something to remember. Both the 3x and the 4, both of them get their own 3. You multiply 3 times both of them. Both the x and the 1 get multiplied by 3. So whenever you see an x plus h or an x plus 1, don't just stick the h on at the end. Make sure the h goes through the same process with the x. Okay, woohoo. So I'm going to stop there because the next video is going to be a bunch. So I encourage you to stop right here, practice with some of the homework. The next thing we're going to go on to is something that's really, really important. It's something called, and I know this looks dun dun dun, but I'm giving you a preview. This is something called the difference quotient. And it is a very big part of where we're going with algebra and then, of course, with calculus. So take a moment, practice this in the homework, ask me questions, ask the tutors questions, then take a nice break, get hydrated, get a snack, get out and see something beautiful in the world, pet your animals, tell someone you love them, and then come on back and we'll do some more work in math. Woohoo! Okay, math on, guys.